Good morning, students. In today's session, we are going to learn the rate of change of quantities. The rate of change of quantities means the word rate of change is related to derivative of function. At last, the derivative of function are constantly used in everyday life to help measure how much something is changing. They are used in government census and various types of sciences and various other areas. So let's begin with basic meaning of rate of change. So for that, suppose that y is equal to f of x is any function with the variable x. We choose y is equal to f of x is any function. Okay. Here the variable x, for variable x we will choose the small change in x, that is delta x. For variable x we choose small change in x as a delta x. So similarly the corresponding change in y will be assumed as a delta y. Okay. Now derivative talks about change in any quantity with respect to other quantity, that is delta y upon delta x. It is related to derivative of change in y respect to change in x, and that delta y upon delta x is talks about average rate of change. That delta y upon delta x, it talks about average rate of change. However, let delta x tends to 0. We choose delta x value is almost close to 0. Then delta y upon delta x is approximately equal to dy by dx. And everyone, we are familiar with this notation dy by dx, that is derivative of function y respect to x. In short, the change in y with respect to change in x. So that is called as a instantaneous change of quantity, that is rate of change. That is called as a rate of change. Okay, so this is a rate of change of any quantity respect to that any function y is equal to f of x. Okay. Now before we start with daily life examples, we have to clear some important aspects. So first see here introduction. So in every example we have to introduce a function. So that functions will be used by variable. Okay. So that by for example, the functions will be the area, volume, the area of a functions related to radius, and those type of variables we have to introduce. Figure. Sometimes we have to use the proper figure to understand any example. Second point, in given formula, so many variables will be, so many points will be there. So out of that, the given things must I have to assume as a constant except variable. So rest of the all quantities will be constant quantities. Okay. Next, third one is as a dy by dx, that derivative of y respect to x is greater than 0, then entity is increasing, and derivative of y dy by dx is less than 0, then entity is decreasing. Okay. Next one is a formula. So the formula of a example depends on given question. So that first formula we have to understand, and then once you understand with the formula, then we have to check it should be of a one variable. If more than variables are there, try to convert into one variable. Okay. And last, the conclude with proper units. So each and every example you must have to conclude with proper unit. Okay. So now let's begin with one by one examples. See the first example. This example we already done so many times. This type of things. Most of the times see that the stone we are taking the stone and we are throwing the stone into the pond, and that times the circle waves are forming. So like that example is there. So it is simple daily life example that a stone drop into the pond, the waves in the form of circle generated, and the radius of outermost ripple increases at the rate of 2 inches per second. How fast the area increasing when the radius is a 5 inches, and we have to find the same how fast the area is increasing when after the 5 second, after time 5 second. So see that, so when you're throwing a stone into the pond, suppose like that, the stone it is in middle is that, and then when you're throwing the stone into the pond, what happens, the circles are started forming when it touches the surface of the water. That stone when touches the surface of the water, it started forming the circles, and that circles, you know that circular waves are forming, and after few seconds that all the waves are vanish. Okay, but what happens in that case, the small circle where it started that become big one. So it means the circle is going to change. So it means there is a change in circle. Okay, so where there is a change in circle, at the same time the circle is formed by using radius. So automatically for the small circle the radius is small, and for the last biggest circle radius is big. Okay, it means that at the same time there is a change in radius, and these all the things that change in circle, that is change in area of circle and change in radius, it is respect to the time, because before the time when that stone not touching the surface, that time there is nothing happening on the water surface. When it touched the water surface, that times it started forming ripples. These ripples are the circular ripples, because of that we are using here circular waves. Okay, so that circular waves in the form of circular waves. Is that clear? So now we have to be clear with these basic things. It means in this example, what is going to be changed respect to time? Respect to time, there is a change in the radius. Also, there is respect to change in area. And see that they ask the question respect to change in area. Okay, and they given that the change increase the rate of a radius of outermost ripple increases at the rate 2 inches per second. It means they provided us change in radius respect to time. So that we have to write in terms of derivative definition, that is rate of change. Okay, so for this form already I given the main important points before starting with example. So we have to understand which are the introduction with the function. So in this example, question is related to area, so our function is area of a circle. Okay, so let's begin with solution. So let R be radius of circle at any time t. Therefore, A is equal to area of circle is equal to pi r square. Everyone know the simple formula for area of circle. Okay. So now all the things are going to change respect to the time. So therefore we use the function A is equal to pi r square, and now we are going to differentiate this function with respect to time t, because area and radius are changing respect to time t. So that is dA by dt, that is change in area respect to time t, is equal to dy dt of pi r square. Now pi is a constant quantity that I will take outside, and then I will take d dt of r square. Now derivative of square we have to find. So but in derivative we learn one formula, dx of x raised to n is n into x raised to n minus 1. But when you finding derivative of x respect to x, this formula hold. Now here we are finding derivative of r respect to t. So that time first we will simplify this power respect to this formula, that is 2 into x raised to n minus 1, that is r raised to 2 minus 1, and we assume r at a place of t. So because of that we have to multiply with rate of change in radius. respect to time. Okay, so therefore we get dA by dt is equal to 2 pi r into dr by dt. Okay, now read it the question carefully. In that questions they already given that the radius of outermost ripple increases at the rate of 2 inches per second. It means for radius they given rate of change, that is rate of change in radius they already provided. So is equal to 2 pi r into 2. Okay, since dr by dt is equal to 2 which is provided, therefore dA by dt, that is change in area respect time t, is 4 pi r. Okay, so this is a function with the variable area and the radius we have. Now start with one by one questions which they ask. So now we have to find how the fast area is changing. It means we have to find change in area respect to time t when radius is 5 centimeter. So first case, when r is equal to 5, dA by dt is equal to 4 into pi into 5, that is 20 pi. Okay, so that is therefore dA by dt is equal to 20 pi. The answer of the question we got, first question we got. And now for area, its units is a inches square and the time is a units here given second. So it is a inches square per second. Don't forget, this is a very important statement. Okay, that is how the area will be changed. The area will be changed when the radius is 5 inches is 20 pi inches square per second. Second question. In second question, after the 5 second, what is a change in area we have to find. Okay, now see here, they are provided change in radius. Okay, now change in radius they given as a 2 inches per second. Okay, so radius will be changed at rate 2 inches per second. So for per second it changed into the 2 inches per second. So after 5 seconds, what should be the radius? So radius after 5 seconds is equal to 5 into 2, that is 10 inch. Okay, so after 5 seconds the radius will be 5 into 2, that is 10 inches, because the radius is changing at rate of 2 inches per second. So after 5 seconds it will be the 5 times of 2, that is 10 inch. Therefore dA by dt is equal to 4 pi into 10, that is 40 pi, and its units is inches square per second. Okay, so see the simple example when we are doing, that is the questions will be also the part of daily life. So such type of example also will be considered in rate of change of quantities. So see the solution properly and note down in your notebook. The next example which is familiar to us is the sand is pouring at the rate of 12 centimeter cube per second. It means what we are taking the sand in hand and we are leaving that sand small little is slowly. So that times what happens, there should be a cone will be formed on ground. In such way that now for this question, for that part, the falling sand forms a cone on the ground in such way that the height of cone is always 1 by 6 of radius of a base. How fast the height of a sand is increasing when height is 4 centimeter. It means we have to find change in height when height is 4 centimeter. Okay, but see first clear the what is the meaning of question. So when the sand is pouring from the hand, there is a formation of a cone. Okay, for cone there is a height and there is a circular base. Because of circular base there is a radius. Okay, so that is an example we have to understand. So this is a cone. Okay, now see there what happens at when the time is 0. It means when when the sand from your hand is started moving, that time if it is the time is 0, then there is a start with forming small thing. It means what happens at time is 0, there is a 0 height, 0 radius, and when the time starts there is a started of forming cones. Okay, so that times what happens, there will be change in radius, also change in height and change in volume. So in this question there are three variables, that is a volume, height and radius. Okay, so that first thing must be clear. And the question is related to height. So it means that everything must be converted in terms of height. Okay, so we have to understand what is the change in volume and what is the change in radius. That also will be clear. So for that, let's begin with solution. So here let R be the radius of a base and H be height of a cone at any time t. Okay, now we know that volume. So we know that volume V is equal to, what is the volume formula? V is equal to 1 by 3 pi r square h. Okay, 1 by 3 pi r square h. Now here the sand pouring at the rate of 12 centimeter cube per second is given. It means what is the given? There is a change in volume is provided. So here change in volume can be written as dV by dt, and given here 12 centimeter cube per second. Okay, at the same time they provided us that the height of the cone is always 1/6 of radius, that is h is equal to 1/6 of r. Okay, therefore r is equal to 6 times of h. So radius easily convert in terms of height. So now begin with the function. Your function is a volume. So V is equal to 1 by 3 pi r square h. So 1 by 3 pi, value of r is a 6h. So it is 6h square into h. That is 1 by 3 pi 36h square into h. To simplify it, 12 pi h cube volume. Okay, so we got that volume 12 pi h cube. Now we will find the derivative of this function respect to time t. So differentiate with respect to t. So therefore dv by dt is equal to d dt of 12 pi h cube. Now 12 and pi is a constant term, we will take outside and we will find d dt of h cube. Again we will use here x raised to n formula of derivative. Respect that formula, 3 into h raised to 3 minus 1 into dh by dt, that is rate of change in height respect to time. Therefore dv by dt is equal to 12 3s are 36 pi h square into dh by dt. Now provided us dv by dt is a 12. So 12 is equal to 36 pi h square into dH by dt. Now therefore dH by dt is equal to 12 upon 36 pi h square, that is 1 upon 3 pi h square. Okay, and now we have to find rate of change in height when height is 4 centimeter. So here only we will do for h is equal to 4 centimeter, dH by dt is equal to, substitute h is equal to 4, that is 1 upon 3 pi h square, that is 4 square. So 1 upon 3 pi into 16, that is 1 upon 48 pi, value of dH by dt. And now for this dH by dt, unit is, height is given in terms of centimeter, so that is centimeter per second. Okay, so it is a very important part is conclusion of this example. So please check the simple example. So that is a daily life example. We always know these things, but we don't know that example also will be related to derivative, that is the rate of change of quantity, that also will be used in such type of examples. Okay, see the example properly and note down in your notebook. Okay, next question. The next example, there's experiment, so many students you done that soap bubble. You always, so many times you played with soap bubble. So see that what you're doing when you're taking that needle and you are blowing that air. So that times what happens, automatically they started a formation of soap bubble. But when you start with blowing air, that time the bubble will be small, and when you how much you time spend, that bubble will become bigger, and after some time it's evaporates. Okay, so now that example also will be the part of rate of change. Okay, so now in this example, see that what is given, the spherical soap bubble is expanding so that radius is increasing at the rate of 0.02 centimeter per second. So at what rate surface area is increasing when radius is 5 centimeter? It means for the spherical bubble, it is in the form of circle, so it's having surface area. So that surface area, it should be clear. So that surface area is changing from as a time spent. Okay, so for that they provided us rate of change in radius is a provided, that is dr by dt is a given. Okay, so in this example, first we have to clear what is the surface area. So for this, let r be the radius of soap bubble at any time t. Therefore surface area S is equal to 4 pi r square, the simple formula for surface area. So now we are going to differentiate that formula. So differentiate with respect to t. So that is, we will get rate of change in surface area with respect to time t, that is ds by dt, and rate of change of 4 pi r square. Now in that case, 4 pi is a constant term, so we will find derivative of r square. So now derivative of square we already done, 2 into r, and derivative of r, that is rate of change in radius with respect to time t. Therefore rate of change in surface area is equal to 8 pi r into dr by dt. So here they provided us the rate of change in radius. So therefore dr by dt is provided as a 0.02 centimeter per second. Therefore, ds by dt is equal to 8 pi r into 0.02. Now we have to find change in surface area when radius is 5 centimeter. So when r is equal to 5, ds by dt is equal to 8 pi into 5 into 0.02, that is 8 pi into 0.1, that is 0.8 pi ds by dt. So multiplied properly, it is 0.8 pi. And now for this question, S is the area, so area unit is a centimeter square, and for time is a second, so it is centimeter square per second. Okay, so the surface area is increasing at rate of 0.8 pi centimeter per square per second when radius is 5 centimeter. Get it? So this, in this example also we will use the rate of change formula. Okay, next question. So the next example, the surface area of spherical balloon is increasing at the rate of 2 centimeter per second. So at what rate volume of balloon is increasing when radius of balloon is 6 centimeter? Okay, so first understand that what is the meaning related to this question. So first we have to clear that the balloon. So balloon, everyone know that balloon, how we are doing with that part. So when you blowing the air inside the balloon, there is a change in spheric, there is a change in surface of that balloon. So that surface of the balloon is started increasing. It means there is a instantaneous change in surface. So that change will happen because of change in radius. At the same time, there is a change in volume of balloon. Get that? So that means in this example, there is a change in radius, there is a change in surface area, and there is a change in volume. So these are the three variables of this question is there. Okay, now after that, given by the given quantity, we have to find the value which they ask. So here first thing is that what are the given things are here. Okay, so let's begin with solutions. First, let r be the radius of spherical balloon. Okay, then SB surface area and VB volume of balloon at any time t. Okay, so now the formula, therefore S is equal to 4 pi r square and V is equal to 4 pi by 3 pi r cube. 4 pi by 3 pi r cube. Okay, so now we have to start with differentiation. So differentiate with respect to t. This also differentiate with respect to t. Now differentiate the first part, that is ds by dt, change in surface area respect to time t, is equal to d dt of 4 pi r square. Now 4 pi is a constant term, so d dt of r square, and 4 pi derivative of r square is 2r into dr by dt. Therefore ds by dt is equal to 8 pi r dr by dt. Similar way, we will differentiate the volume. So change in volume respect time t is equal to d dt of 4 by 3 pi r cube. So now 4 by 3 pi constant term, so we have to find d dt of r cube. Now respect to the x raised to n formula, derivative of r cube is 3 into r square into derivative of r is dr by dt. So therefore dv by dt is equal to, this 3 get cancelled, 4 pi r square dr by dt. Okay. Now by using ds by dt, see that, so value of ds by dt, value of ds, change in spherical surface area change is already provided, that is value of ds by dt is provided. So therefore 2 into 8 pi r dr by dt. Therefore dr by dt is equal to 2 upon 8 pi r, that is 1 upon 4 pi r. Value of dr by dt by first part. Now we will check with dv by dt. So therefore dv by dt is equal to 4 pi r square, and value of dr by dt will substitute, that is 1 upon 4 pi r. So what will happen? So cancellation will happen, and after cancellation we will get dv by dt is equal to r. Cross check it again. So 8 pi r dr by dt. Okay, so dv by dt is equal to r, and now they ask the change in volume when radius is 6 centimeter, that is dv by dt is equal to 6 when r is equal to 6. Hence dv by dt is equal to 6 centimeter cube per second. Okay, so this is required change in volume of spherical balloon when radius is 6 centimeter. So please check the example properly and note down in your notebook. So these are the examples of a rate of change of a quantities which are related to our life. So also we can use derivative in our daily life. Okay, so these examples will help us to understand daily life examples related to rate of change of quantities. So everyone clear with that point? So now here we stop with this point, and in today's session we finish with rate of change of quantities. Now in the remaining time you have to practice one more activity I will send with PDF. Okay, and now if you have any doubt with any one of the point, please let me know. Okay, thank you.